Hello everyone, welcome to my presentation on the Speaker Project. My name is Osia Lara, and I am currently enrolled in Engineering Architecture 2 at Joliet Central High School. The project began in AutoCAD. I first had to draw pieces for my speaker in the cut layer. The goal was to design each piece with different and unique designs. Once I got the images to AutoCAD, I placed them in the construction layer and turned off the visibility of the drawings and used the spline tool, a tool that allows me to create smooth curved lines to trace over the image. Every piece except the last piece utilized this spline tool. The second most utilized piece in this project was the path array, a tool that allows you to make a pattern that follows a path. You can see the path array being used in my first piece, third piece, and last piece. Once I got my pattern set and done, I offsetted my drawings and hatched the space in between them to make the images pop out more. This process wasn't exactly as straightforward as I expected it to be. I had been having issues with hatching the line pattern in the vibe zone piece. The hatch just wouldn't work and it would just crash AutoCAD. The AutoCAD feature that I learned during the making of the speaker was line weight. Instead of hatching, I clicked the lines I had already drawn and changed the thickness of it and used this as a hatch substitute. Now with the hatch issue now out of the way, it was smooth sailing from here. I used the copy tool and the scale tool to quickly and efficiently finish the patterns in my design. These are the final AutoCAD drawings, with the designs finalized and ready to be laser cut. You can see three of my pieces being cut in the left corner. I laid out all my pieces on the bottom right corner image, and they turned out really well. With all of my pieces being cut, I was able to begin construction of the physical speaker. I started with the dry fit assembly. The dry fit assembly allowed me to check for any errors that could have occurred to one of the pieces while it was being cut. It also allowed me to troubleshoot any issues before getting to the gluing process. The pieces fit together perfectly, and none of them were cracked or had any cutting errors. With the dry fit step out of the way, I grabbed the speaker kit and took out the speaker and the controls. I laid the corresponding parts over the pieces that I wanted to insert them in. I inserted both the speaker parts by pushing them in by both sides and applying force which were spread out along the diameter of the holes. Thankfully, none of the wood pieces cracked during the installation of the speaker parts. I began by using the bottom piece as my foundation. I first glued the right and left piece together, which were the ones with the speaker parts first, and followed by gluing the front and back pieces next. I grabbed a couple books and surrounded my speaker with them. The books were to make sure that the pieces stayed together while the glue began to dry up. As soon as the books were set, I put on the top piece on the speaker to make sure that the speaker kept that cube-like shape and the top piece would actually fit once the glue was done drying. I didn't glue the top piece onto the other pieces though. It was left unglued to make sure that I had easy access to the interior of the cube in case something went wrong and I had to open it up. Now, I glued these parts together in hindsight, terrible way. I present to you the consequences of my actions. The weird way I glued pieces together made it so that my right and left pieces weren't standing completely straight up, leaving a gap between my left and right pieces compared to my top piece. Now, what I should have done was glue the right or left piece with one of the pieces that would go adjacent to it. This will provide support that would make my pieces stand up straight during the drying process. With this crisis in my hands, I had to get crafty. What I did was flip over the speaker to its side, making it so the right side would be facing up and the left side would be facing down, and inserted glue in between the open gaps. I then placed two pokes on the top of the right piece to put pressure on it and put a few Q-tips on the bottom to make sure the left piece was also getting readjusted. As you can see on the right, this actually solved the problem. The gap in between the right and top pieces were non-existent, and the gap between the left and top piece was nearly closed. I would show you I would show you a before and after, but I was too focused on solving the issue at hand that I didn't take any pictures of the massive gaping holes in my pieces. Once the gluing was officially done, I began to set up the lights. I would have preferred to place the lights along the interior of the walls of the speaker, but an oversight was that I had holes on the corner of the pieces, meaning that if I were to run lights along the walls, it would corrupt the holes. Sadly, I didn't have a solution for this issue like I did with my offsetted right and left pieces. All I could do was take a mental note, take a, all I could do was take a mental note of this and prevent this mistake from happening in the near future. The best thing I can do was uncoil the lights and let them run wild. With everything checked off the list, I had finally finished my Bluetooth speaker, and as soon as I got home, I tested the lights out and made sure I was able to connect to the speaker and play music. This is my Bluetooth speaker in three different colors: purple, green, and cyan. In conclusion, the speaker project was a surprisingly fun project that I was able to learn a lot of different things from, the different aspects of the construction process, ranging from the design error of having holes along the corner of the walls, preventing me from setting up the lights, to learning a new AutoCAD tool to bypass errors. I'm sure that whenever I glue something together in the near future, I would instantly remember the massive gaping holes in my speaker. This is my presentation. Thank you for your time.